Welcome to Lesson 18, Ratios in Right Triangles. As mentioned previously, trigonometry is the study of the measure of triangles. Today we're going to learn about yet another set of properties that are specific to right triangles only. So it's very important to notice that trigonometric ratios are the ratios of the measures of two sides of a right triangle. It can be very tempting to use these handy ratios for other triangles, but they only work when you're dealing with a right triangle. Somewhere along the line in math, you may have heard the abbreviation SOHCAHTOA. And if you always wondered what that meant, now's your chance to find out. SOHCAHTOA is a mnemonic that we use to remember how these ratios work. So, for example, if I have this triangle, ABC, which is a right triangle, with C, of course, being the hypotenuse, if I wanted to find out what the measure of the angles of this triangle are, I can use the properties of sine, cosine, and tangent. To find the sine of an angle, and in this case, I'm going to examine angle A, I simply have to divide the leg that is opposite of angle A, which is A, and divide that by the hypotenuse, which is C. So we say opposite over hypotenuse. It is sometimes abbreviated O over H, which gives us SOH. Sine is opposite over hypotenuse, and we call that SO. When writing sine, we actually abbreviate sine without the E, so it looks like sin A. So to find the opposite over the hypotenuse in this particular triangle, I would use the length of A over the length of C. If I wanted to find the cosine, I would use the adjacent over the hypotenuse. So again, if I look at angle A, adjacent would be the leg that is immediately adjacent to the angle. In this case, that is B, and I would divide B by the hypotenuse. Since we say adjacent over hypotenuse, that gives us the abbreviation CAH. So I have SOHCA. To find the tangent, I start with my angle A again, and I would use the opposite leg, A, and I would divide it by the adjacent leg, B. So I have A over B in this example. Tangent is opposite over adjacent, which gives us TOA. And that's why you may have heard mathematicians use the abbreviation SOHCAHTOA. It's to help us remember what the specific ratios are. We're going to take a look at the triangle below and use these ratios to find out about the angles of this particular triangle. In looking at this triangle, I'm dealing with angle S. I should note that these ratios work for any angle. You would rarely use it for angle that's the right angle because you already know it's 90 degrees, but I could also use this for angle B in my example above. I could have found the sine, the tangent, and the cosine, and I could do it for A or B. So in this particular example, I want to find out about angle S. So I'm going to use sine is opposite over hypotenuse, which in this case means the opposite leg is 3 over the hypotenuse of 5. So 3/5 equals 0.6. To use the cosine, I would start at angle S, and I would use the adjacent leg, which in this case is 4, over the hypotenuse 5. And 4/5 simplifies to 0.8. If I wanted to use the tangent, I would start at angle S, and I would use the opposite leg over the adjacent leg, which gives me 3/4 or 0.75. At this point, you might be wondering, and what am I going to do with these decimals exactly? That's nice. I can say I know the sine, but I still don't really know anything about angle S. This is where you can learn to use the inverse of the sine, cosine, or tangent to find an angle measure. So for example, if I know that sine S is 0.6 as calculated above by the opposite over the hypotenuse, I can use my calculator to work backwards, so to speak, or find the inverse of sine to get the angle measure. Using my calculator, I would press the second button, the sine button, the sine that I calculated from my exact triangle, and equals, and it will tell me the measure of that angle. In this case, the measure of angle S is 37 degrees. So let me show you exactly how to do that on a calculator. On these calculators, always start by clearing your calculator, of course. The sine button is up here, and it's followed by the cosine and the tangent. The second button can be used for an inverse. So if I want to know what angle has a sine of 0.6, I press second, sine, and you'll see parentheses pop up. See if we can get that in there. There we go. So you can see that sine to the -1 indicates an inverse. You'll remember in algebra that an exponent of -1 means 1 over something. So this is actually the inverse of sine. I'll put in 0.6, close my parentheses, and when I hit equals, it tells me 36.869 on and on. I can round that up to be 37 degrees. So this tells me that the measure of angle S is 37 degrees. If I knew what the angle was and I wanted to find out what the sine is, I would use the sine button without the second. So for example, I could clear this and I could say that I would like to know what is the sine of an angle that is 37 degrees. I would do sine, my parentheses pops up, I put in 37, close my parenthesis, and I get 0.6018. So it doesn't match our 0.66 exactly, but you can see that we were rounding a little bit. Okay? If I want to examine angle E over here, I can use the same relationships to find out the measure of angle E. In this case, my sine would be the opposite over the hypotenuse, which would be 4/5. So 4 divided by 5 is 0.8. My cosine for E would, of course, be the adjacent over the hypotenuse, or 3/5, which equals 0.6. And my tangent would, of course, be the opposite over the adjacent. So this time I'll actually get a number that is greater than 1, and I get 1.3 repeating. If I wanted to find the measure of angle E, I could use the sine, I could use the tangent, or the cotangent. Just to make the example a little broader, I'm going to use cosine this time. So I know that cosine of E is 0.6. So similarly, I would put in second cosine in my calculator, 0.6. So here's my calculator, and I have second cosine 0.6, close the parentheses and hit equals, and I get 53.130, and it goes on, and I would round that to 53 degrees. As you would note in this particular triangle, that sounds correct, because the sum of all three angles should always be 180, and if I add 37 and 53 and 90, I get 180.